and welcome to today's class. So today we'll be solving the paper FM of 2026, paper 32. And this is the new paper that has been released a few months before. So let's start. So we have question number 1, and seeing it, it looks like it's from the logs chapter. So solve the equation 4 into 2 power x plus 2 minus 5 into 2 power x minus x is equals to 3. So we can rewrite 4 into, instead of 2 power x plus 2, we can write 2 power x plus 2 as 2 power x into 2. So it will be 2 power x into 2 power 2 minus 5 into, instead of 2 power 2 minus x, we can write 2 power 2 minus x as 2 power 2 plus 2 multiplied by 2 power minus x. So we can rewrite it as that. So we can rewrite everything as 16 into 2 power x minus 5 fours as 20 into 2 power minus x, and we can rewrite 2 power minus x as 1 over 2 power x as well. This will be equal to 3. Now, since we can see that we have 2 power x in the denominator and the numerator as well, we can simplify and take this as common and cross multiply. So we can let y is equals to 2 power x to make our working way more easier. So 16y minus 20 over y is equals to 3. 16y square minus 20 is equals to 3 over y, and this 3 cross multiplies. So 16y square minus 20 minus 3y is equal minus 20 minus is equals to 3y. 16y square minus 3y minus 20 is equals to 0. So we can solve this quadratic equation now, and we'll have two solutions. So y will be equal to, let's check through the quadratic formula. So 16 minus 3 minus 20, y will be equal to 1.2157, or either y will be equal to minus 1.028. Now we can replace it with 2 power x is equals to y as well. So we can substitute it back, and 1.2157. Then we can, to get x, we can ln both sides. Ln both sides. So ln 2 power x is equals to ln 1.2157. And this can be rewritten as x ln 2 is equals to ln 1.2157. And x will be equal to ln 1.2157 divided by ln 2, and the answer will be the answer will be 0.28178. Now the question asks us to write it in 3 significant figures. So we'll rewrite it as x equals to 0.282, and that will be our final answer. And whereas for the other solution, we can rewrite 2 power x equals to minus 1.028, but we have to ln both sides, or put log both sides. But ln of a negative number has no solutions, so no solutions on this end as well. So we'll only have one answer, and that is the correct answer.
Question number 2, we have the complex number satisfies the equation such as the distance of z from 0, 0 is 9. So the distance of z from 0, 0 is 9. So this would mean a circle with the center of 0, 0 and radius would be 9. So that would be our first construction for the diagram of z. And then the argument of z goes from 90 to 180, or pi by 2 to pi. So it would be from this axis to this axis. So first up, to satisfy the first one, we'll create a circle with radius 9 and center this. And then to satisfy the second one, we'll just cut the radius off of this, cut the circle off of this. So it will look somewhere around like this. This would be the arc. Then we have on the same diagram, sketch the locus of points representing the conjugate of z plus 3. So if conjugate z is equals to x plus iy, the conjugate of z would be x minus iy. And we have to plus 3, that's so x plus 3. So the real part of z becomes x plus 3, and the imaginary part of z becomes minus y. Imaginary part of z, conjugate of z becomes minus y. So minus y would mean that, for example, if we have this construction over here, so this would go from minus 9 to plus 9 to minus 9. So that would mean that the argument is basically shifting. So at this point the argument is pi by 2. This is going to minus pi by 2. Whereas at this point the argument is minus pi, sorry, and this would lift to pi minus pi. So this would be somewhere like this. And then our new center is this. So x plus 3 would be around here. So if we have to basically create a circle that shows pi by 3, and that would basically be minus 6 and 3 over here, because this distance would be 9 since we're changing the center. So this would be the minus pi, and this would be the plus 0's distance. So it would somewhere be around like this, and that would be our argument. So that would be the construction. I'm not still sure about the second construction, since we don't know if we have to construct it accordingly. So it could either be somewhere around this one, or it could be something around this one as well. So that's for question number 2.
Moving on to the question number 3 of this paper, FM 2026. So we have the integral of 3 sine x sine 2x. So instead of sine 2x, first of all, off the bat, we can rewrite sine 2x as 2 sine theta cos theta. So we can substitute this. So it will be 3 sine x into 2 sine x cos x, and it can be rewritten as 6 sine square x into cos x. So we can take 6 out of the integral, and the thing that will be left is sine square x into cos x dx with the limits of pi by 4 and pi by 3. Now, since the derivative of sine x is cos x, and we have sine as power 2, so sine square x. So for us to apply the power rule, the differentiation of this box has to be present outside. It says, let's say this is a box, and the differentiation of this box will be cos x, and that has to be present, which is already present. So we can just use a power rule here. So we can write 6 and then mod of sine x power 3 divided by the new power, which is also 3 as well. So that will be our integral, and we'll have the limits as pi by 4 and pi by 3. Then we can apply the limits, so the answer will be 6, and then sine of pi by 3 is sine of 60. Sine of 60 is root 3 over 2. So we can write root 3 over 2 cubed, and then we can divide it by 3, and then we can subtract it by sine of pi by 4 is 1 over root 2, or root 2 over 2. So root 2 over 2 cubed divided by 3, and then the answer will be it will be root 3 over 8 for here, and minus sine of pi by 4 is root 2 over 2, and cubed it divided by 3 will be root 2 over 12. Now if we multiply 6 by the entire equation as we wrote it before, so it will be 6 over 8, 6 root 3 over 8 minus 6 root 2 over 12, and then if we simplify it further, 6 over 8 can be written as 3 over 4, so 3 over 4, and then root 3 minus 6 over 12 can be written as root 2 over 12 over 2, and that will be our answer. And we have to give the answer in the form of p root 3 and q root 2. So p will be equal to 3 over 4, and hence q will be equal to minus 1 over 2, and that is the correct answer as well.
On to the fourth question. So it is a question of binomial, and this is the binomial of P3. So the coefficient of x3 cube is in the expansion of 1 minus ax in 2. So the random or the general equation is 1 plus x over n. So our new n x would be equal to minus ax, right? So we have to find the value of a, so we have to find the corresponding x cube coefficient. So if you check the formula sheet, the way to do that would be n minus 1 into n minus 2. So 1 plus nx plus n minus 1 x square plus n minus 1 n minus 2 x cube over 3 factorial. So our n is 2 over 5. So 0.4 into 0.4 minus 1 into 0.4 minus 2 into minus ax cube. So minus ax x cube here would be minus a cube x cube. So it multiplied by minus a cube x cube divided by 3 factorial would be equal to 1 x cube. Now if we simplify that all, so it would be 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial. It would be 8 over 125. 8 over 125 x cube would be equal to 8 over 125 a cube x cube would be equal to 1 x cube. So a cube will be equal to it goes on to that side and x cubes cancel it. A cube will be equal to 125 over 8 and a will be the cube root of that. So a will be equal to 5 over 2, and that is the correct answer for it. Then we have to find the coefficient of x power 4 in the expansion of 2x plus 1 and 1 minus a. So it could either be that we have the coefficient of 1x cube plus coefficient of x power 4 multiplied by 2x plus 1. So the one way to do that would be that we multiply the coefficient of x cube by 2. So it would be 1x cube into 2x would be 2x power 4. So we already have the coefficient of x power 4. Now we needed to get the second coefficient and then we'll multiply it by 1. So second coefficient we can take it out by binomial theorem. So we can use a similar formula. So n minus 1, n minus 2, n minus 3 divided by 4 factorial into a power 4 into x power 4. That would be our expression. So if we do that by the calculator, so it will be 0.4 into 0.4 minus 1 into 0.4 minus 2 into 0.4 minus 3 divided by 4 factorial. It would be minus 26 divided by 625 and will multiply it by a power 4. So multiplied by 2.5 power 4. So it will be minus 13 over 8 x power 4 and will multiply it by 1. So our total coefficient will be 2 minus 13 over 8 x power 4, and if we simplify that, the answer will be 29 over 8 x power 4. Moving on to C, so state the set of values for x for which expansion of 4b is valid. So expansion of 4b would be valid when this is valid, and the binomial to be valid, we know that the mod of x would be equal to less than 1. So the mod of here the x is minus a, so minus ax. So and a is 2.5. So 2.5 minus 2.5x would be equal to, what should be less than 1, since it's a mod, so minus sign automatically doesn't matter. So 2.5x is modulus, or 5 over 2 x is modulus would be equal to less than 1. This goes on to that side, so modulus of x should be less than equal to 2 over 5. We can either write it like that, or we can write it minus 2 over 5 is x is greater than or equal to minus 2 over 5 and less than equal to 2 over 5. Both are correct, and that's it for this question. Question number 5. We have to find the value of lambda for which argument of z equals to pi by 4. So argument of the formula for argument is tan inverse of the imaginary part divided by x. So let xz is equals to f x plus iy, then y over x will be the argument of x would be pi by 4. So the y by x will be equals to tan of pi by 4, and tan of pi by 4 is basically 1. So hence the y is equals to x, or basically the imaginary part of z is equals to the real part of z. That's the first equation we have. Now we will first see what is the exactly is the imaginary part. So 3 plus lambda I divided by lambda plus 2i. If we have to remove this I imaginary part from the denominator, we can conjugate it. So we'll multiply it by lambda minus 2i and then lambda minus 2i, and then we can cross multiply. So in the denominator it will become lambda square minus 2i whole square, with 2i whole square would be, it would be plus 4i, because I square is equals to minus 1, and then we'll have in the numerator this whole stuff. So we can write 3 lambda plus minus 6i plus lambda square I and plus lambda I into 2i, so minus 2 lambda I square. Since I square is minus 1, so this we can write it that minus 2 into minus 1 lambda into minus 1, which will basically be plus 2 lambda. Now if we group it together, so our real part would be 3 lambda minus plus 2 lambda, which would be 5 lambda divided by lambda square plus 4, and our imaginary part would be lambda square minus 6i divided by lambda square plus 4. Now we can equate both of these, since we derived that in the first equation. So 5 lambda divided by lambda square plus 4 is equals to lambda square minus 6 divided by lambda square plus 4. So we can divide or remove lambda square plus 4 from both sides. It's a constant, so it will be lambda square minus 6 equals to 5 lambda, and then we can calculate this whole. So lambda square minus 5 lambda minus 5 lambda minus 6 will be equal to 0. Now we can use the quadratic formula or the quadratic equation function to solve. So 1 minus 5 minus 6 would be give us the lambda is minus plus 6, and the other value of lambda would be minus 1. So lambda has to be greater than 0 in order for this to be fulfilled, because if lambda was minus 1, so it will be, so it would not give it would not dissolve to the condition, so lambda would be equal to 6, and that would be our value of lambda. We could omit this solution. When lambda has a value found in 5a, find the exact value of the modulus of c. So modulus of this formula is root of y square plus x square. So the real part of z, the value of real part of z could be 5 lambda divided by lambda square plus 4. So 5 lambda is 30. So 5 6 are 30 is 30, 36 plus 4 would be 40, and then for the imaginary we can rewrite this as 3 over 4, and for the imaginary part of c we can write lambda square minus 6, so it would be 36 minus 6, which is basically 30, divided by lambda square plus 4, which is basically 40. So this is also 3 over 4. So our answer will be 3 over 4 square plus 3 over 4 square under root. So our answer would be, if we calculate it, 3 over 4 square plus 3 over 4 square, and the answer would be root of 9 over 8, and the exact value would be 3 over root 8, and if we conjugated it, so root 8 over root 8, so it would be 3 root 8 over 8, and that would be the final answer. Or we can conjugate it further as well, so it will be 3 root 2 divided by 4. That would be the final and simplest answer. And that's it for this question. So for question number 6, we have a polynomial equation. It is given that x square plus x plus 1 is a factor of p of x. So the remainder will be equal to 0 if it is divided by this. So that is that. And we can do this by long division either, or we can do this by equating this to 0. So we have the factor theorem such that if p of x minus a is equals to the remainder, which is 0, so p of a will be equal to 0. Either way we can do that, or we can do it by comparing coefficients. So if we have px square plus qx plus c, multiplied by x square plus x plus 1, it will give us the polynomial 2x power 4 plus ax cube plus 4x square plus bx minus 3. So if we compare the coefficients, so p x power 4 is equals to 2x power 4, and then uh, px cube plus qx cube, so like this and this would give us a, so ax cube. So the second equation we have is p plus q is equals to a. The third equation we can have is px square plus qx square plus cx square. So p plus q plus c would be equal to the coefficient of x square, which is 4. The reason why we're doing this is because if you see, this px square will multiply by 1, this qx square will multiply by x, so it will become qx square, and this will multiply by 1. So that is that. We have the third equation, p plus q plus c, and then we can use other equations as well, but I guess that would yield the same thing. So for the other coefficients such as x power 1, so the coefficient of x square is also done. Coefficient of x power 1 would be qx plus c, so it would be qx plus cx. So q plus c would be the coefficient of x power 1. Coefficient of x power 1 is b. That's one more equation we have. And if we talk about the final equation, so c multiplied by 1 would be minus 3. That is also one of the equations. So we can use that now to calculate most of the stuff. So px power 4 is equals to 2x power 4, p will be equal to 2, right? So our p is equal to 2, and then that's our main thing. P plus q will be equal to, and our c is equals to minus 3. So p plus q, 2 plus q minus 3 is equals to 4. So q will be equal to 2 minus 3 is minus 1, and q will be equal to 4 plus 1, which is basically 5. And c is equals to minus 3, p is equals to 2. Now we can use that to find a and b. So a is the value of a is p plus q. So p is 2, q is this. So a will be 7, and the value of b is q plus c. So q plus c is 5 minus 3, and b will be equal to 5 minus 3, which is 2. So a is equals to 7 and b is equals to 2. Then we have second part, so hence shows that to show that factor x plus 3 is a factor of p of x. So p of minus 3 should be equal to 0. That is our main principle. Now we'll put in the values of minus 3 in this. So uh, we'll put minus 3 in the entire equation. So 2 into minus 3 power 4 plus 7 into minus 3 cubed plus 4 into 7 square, sorry, 3 square minus 3 square plus 2 into minus 3 would be should be equal to 0, and then we'll show this side to be equal to 0 by 3 power 4 into 2 plus 7 into minus 3 power 3 plus 4 into 9 plus 2 into minus 3, which will be minus 6 minus 3. So it will be equal to 0. Then 0 will be equal to 0, it is shown. Then that's the way to solve this question.
Up we have question number 7, and in question number 7 we are this is of iterations, I believe. So by sketching a suitable pair of graphs, show that the equation ln x is equal to cosec of half x and has exactly one root in the interval 0 and pi. So we have to just show the positive. So let's say this is 0, this will be around, and this is pi. So the middle would be around, pi by 2 would be around here, and pi by 2 would be here, and in the y-axis we can assume 1 to be over here. That could be our possible scale. So if we draw the graph of ln x, so the graph of ln x would be the graph of ln x is around 0, is 0 at 1. So if we have 1 at this point is 1.7, so 1 at this point around, so the graph of ln x would be somewhere like this. Whereas if we talk about the graph of y is equals to cosec half x, can be written as 1 over sine of half x. So if we talk about 0, so 1 over sine of half into 0 will be 0, and then 1 over 0 will be infinity. So it starts from infinity, and then at pi over 2, sine of pi over 2 would be sine of half into pi over 2 would be sine of pi over 4, and sine of pi over 4 would be basically root 2 over 2. So it will be somewhere around this part, and sine of pi would be sine of pi would be converted into sine of pi over 2. It would be 1 over 1, which would be sine of pi over 2 is 90, so 1 over 1 would be this. So this could be, and since this is 1, that could be it. And yes, so it will basically be somewhere like this, starting from infinity to somewhere like this, and it will intersect at this point, roughly around this point or around this point. Verify by calculation that this root lies between 2.6 and 2.9. So our equation is ln x equals to cosecant half x. So ln x minus 1 over sine of half x is equals to 0. We can take this on that side, right? And then we can replace this 0 by y, or f of x. So y will be equal to ln x minus 1 over sine of half x. And then for root change, we can calculate f of 2.6, which will be basically, and then we will calculate f of 2.9, and f of 2.6 will be minus 0.08, and f of 2.9 would be, it would be around 0.057. So there is a sign change in interval of 2.6 and 2.9. So root lies here, shown. Moving on to the part 3, which is using the formula this. So x equal, first we'll rewrite the formula x equals to e power cosecant of half x. So we can rewrite this as 1 over sine of half x, since the calculator doesn't accept cosecant. And then the first iterations, we can calculate the middle point of 2.76 and 2.9. So x1 will be equal to 2.6 plus 2.9 divided by 2, and the x1 will be equal to 2.75. And then for the each successive iterations, x2 will, so we'll use this one for the first iteration. X2 will be e power 1 over sine of half into the answer, and then we'll put this into the calculator. So e power 1 over sine of half into answer, and our first iteration will be x2 will be 2.77175 to 2 decimal places. Now we'll continue pressing the answer or equals to button on the calculator to get our successive answers, and I'm going to skip writing the successive answers, and then finally we'll get the, when we get two same x's answers, so finally you keep pressing is equals to, you'll get two answers, 2.6707 and 9 and 2.67079. These two answers are same and nothing will change, so we'll just assume the iterations to end here, and we have to give the result to 3 decimal places. So x will be equal to 2.67, and that is the correct answer. Question for differential equation, and to solve this, first we'll isolate the variables. So y into dy by dx into e power 3x equals to x into y plus 5. We take out y we take out y at one side, so y over y plus 5 into dy will be equal to x divided by e power 3x. So we can rewrite this as e power minus 3x. Then and then dx goes on to that side. Then we'll integrate both sides. And then what for if we integrate this side, so integral of y over y plus 5. I don't think there's a direct way to solve this integral or a direct operator, so we can use the long division of polynomials. So y plus 5 will be outside, y will be inside, and the first term will be y, quotient will be y over y, which is basically 1. So it can be rewritten as y plus 5, and then this goes 0 minus 5. So it can be rewritten as y, sorry, 1 minus 5 over y plus 5 dy. And if we integrate this would integrate to give us the answer y minus 5, and then we can use the ln since the differentiation of y is 1. So minus 5 ln y plus 5. So the integral of the left hand side would be y minus 5 ln y plus 5. And if we integrate the right hand side now, integral of x into e power minus 3x. So uh, we can use our integration by parts here. So we can use eyelet to find out which is e, which is u. So this would be v and this would be u. So du by dx would be 1, and then integral of v dx would be e power minus 3x integral will be minus e power minus 3x divided by 3. So and then we'll integrate it with the formula of integration by parts. So u integral of v dx minus integral of du over dx into integral of v dx. So it will be u is x into integral of dv is minus e power minus 3x, and then it is divided by 3 minus integral of 1 du by dx is 1 into minus e power minus 3x over 3. Now we'll take minus as outside the bracket, so minus minus will turn into positive. So positive e power minus 3x dx, and this will turn into the differentiation of e power minus 3x again. So it will be x into e power minus 3x divided by 3 minus e power minus 3x divided by 9, and would be equal to y minus 5 ln y plus 5 plus c of integration. Now y is equals to 0 when x equals to 0. So we can use this to calculate over c. So when x equals to 0, this whole part will become 0, and then when x is equals to 0, this whole part become minus 3 into 0 will be 0, and it will become minus e power 0 would be 1. So minus 1 over 9 would be equal to y 0 0 minus 5 ln y plus 5 is 0 plus 5, so 5 plus c. So our plus c becomes 5 ln 5 minus 1 over 9. And then our differential equation would basically be x into e power minus 3x over 3 minus e power minus 3x over 9 is equals to y minus 5 ln y plus 5 plus x plus 5 ln 5 minus 1 over 9. That would be our final equation, and that is the correct answer as well. So if we have an integration question, so using the substitution x equals to tan 3u, we have to show that I is equals to, so first part is a showing part. So if we have x is as this, so we can take the derivative, so dx over 2u will be root 3, and the derivative of tan x is secant square x, so derivative of tan u will be secant square u, and the differentiation of u, which will be 1. So and then dx will be equal to root 3 into secant square x into du. We can use the substitution inside this integral as well. Now the other part is that we have to convert these x's to y's. So x is equals to root 3 tan u. So the x cube will be equal to 3 root 3 cubed will be and 10 cube u. So this can be rewritten as 3 root 3 and cube u. Then x square can be rewritten as root 3 square will be 3 tan square u. So then we can write the entire thing again as 3 root 3 tan cube u divided by 3 plus x square will be 3 tan square u and multiplied by root 3 secant square u du. Finally, then we can multiply this root 3 by root 3, so it will become 3 root 3 into root 3 will become 9, so it will be 9 tan cube u secant square u du divided by 3, so we can take 3 common here and then we can write 1 plus tan square. So 1, 3 and 1 plus tan square. Now one other thing you notice that we have the identity in the trigonometry that secant square equals to 1 plus tan square, right? And we can divide this 3 and 9, so it will be 3 tan cube u secant square u, and instead of 1 plus tan square we can substitute secant square u again, so we can cancel these both. So our final answer would be integral of 3 tan cube u du, and our limits, so our first limit is 3 and 1 and 3, so change of limits. X is equals to root 3 tan u, so x equals to root 3 tan u, and if we convert this these to the terms of tan, so 1 is equals to root 3 tan u and u will be equal to tan inverse 1 over root 3, and for the second value u will be equal to tan inverse of 3 over root 3, and if we find the answers to both of that, the answers will be pi by 6 for this one, and for the other one they will be pi by 3. So these are the new limits. So we can rewrite this integral as integral of 3 tan cube u and pi by 6 as the lower limit and pi by 3 as the upper limit, and that is shown as it was asked in the question. Moving on to the second part, hence or otherwise find the exact value of I. Give your answer in the form of P plus Q ln R, where ln PQ are rational. So our this is our integral, so we'll integrate it normally. So integral of pi by 3 pi by 6 3 tan cube u 3 tan cube u. Now we can take 3 outside, so it will be 3 integral of tan cube u du, and to integrate tan the odd powers of 10, you have this rule basically that you divide it into even power into tan x. So this will be the method we'll be using. So tan square x, sorry, tan square u, and then we'll write tan u du, and we'll simply integrate it. Now to integrate it, we can rewrite tan u as the trigonometric identity we studied earlier. So 1 secant square is equals to 1 plus tan square. Secant square minus 1 would be tan square. So we can rewrite this by as secant square minus 1. So secant square minus 1 tan u du will be equal to secant square u tan u minus tan u du. So we can integrate this separately, integrate both of these separately as well. So integral of this would be like that, and if we analyze this, the derivative of the dy over dx of tan x will be equal to secant square x. So again we can use a power rule here. So for the first thing we can, since you have the derivative of box present outside, so we can take 10x as the operator and apply the power rule, so it will be 10x squared divided by 2 and minus integral of 10x. and then multiplied by 3, and we have the limits as well, limits. So if we integrate tan x, first of all, we can rewrite tan x as secant tan x. Integral of tan x would be integral of sin x over cos x. Now we also know that f of f, if the differentiation of x is present and difference x is here, the answer will be ln of f of x, right? So the differentiation of sin x is, so cos x is minus sin x, so we can add minus sin x over here, and then we can add minus sin x minus 1 out of the integral as well. So it will be minus 1 integral of minus sin x over cos x. Hence we can rewrite this as minus 1 ln cos x. So our answer will be tan square x minus again of, and then minus again of ln of cos x. So we'll cut the minus sign, so it will add, and then we can add our limits. So it will be pi by 6 and pi by 3. To add the upper limit, we have tan pi by 3. Tan pi by 3's value is root 3, so it will be root 3 square for the first one, and root 3 square divided by 2, which is basically 3 over 2, plus ln of cos x. So cos of pi by 3 is, I guess, 1 over 2. So plus ln of 1 over 2, and then subtracted by uh, tan of pi by 6 square. Tan of pi by 6 square is it would be 1 over 3. So minus 1 over 3 plus ln of cos of pi by 6 is ln cos of pi by 6 would be equal to around ln cos of pi by 6 is root 3 over 2. So plus ln of root 3 over 2. Since you have to give answer in form of ln. So final answer can be written as 3 over 2 minus 1 over 3 and plus ln 1 over 2 minus ln root 3 over 2. Now here we can also use, here instead of 1 over, we will write 1 over 6 because we have to divide this by 2 as well. So that is that, and then here we can use the product rule, oh sorry, the quotient rule of tan x, oh sorry, ln. So ln of 1 over 2 divided by root 3 over 2. So it can be rewritten as ln 1 over 2 into 2 over root 3. 2's 2's cancel, so it will be ln 1 over root 3. And then this will be 3 over 2 minus 1 over 6, and 3 over 2 minus 1 over 6 is 4 over 3. So answer will be 4 over 3 plus ln 1 over root 3. The reason we're not using root 3 power minus 1 and then taking it outside is because root 3 is irrational and 1 over root 3 is not irrational. So that is why, and that is will be our final answer as well.
So the variables x and y satisfy the equation this, where k is a constant, so that dy by dx is equals to 2y. So we have to remove k from the dy by dx equation as well. So this is a question of implicit differentiation. So that we'll take the derivatives on each side. So the derivative of y would be 2y dy by dx, and then derivative of this would be is equals to k, and then derivative of x minus 2 over x plus 2. So we can use the the quotient rule over here. So the quotient rule states that the differentiation of u would be v u differentiation minus u v differentiation divided by v square. So we can rewrite this as, this would be u and this would be v. The differentiation of u would be 1 and the differentiation of v would be 1 as well. So v is x plus 2 multiplied by 1 minus x minus 2 divided by x plus 2 whole square. This would be a derivative, and then we'll multiply k as it is. So if we simplify it further, x here will minus x, so it will be x minus x is 0, and then 2 minus minus 2 will be plus 4. So we can rewrite this as plus 4, and then the k will multiply in, so it will be plus 4k. That will be our 2y dy by dx. So our dy by dx would be equal to 4k divided by 2yx plus 2 whole square, and then this gets cancelled, so it will be 2k over y into x plus 2 whole square. Now the issue is that we don't know the value of k, so k is still in the equation, but one thing we can do is that we can make k the subject of this equation. So y square into x plus 2 divided by x minus 2 will be equal to k from this equation. So if we substitute it over here, so instead of k we'll write 2 into y square into x plus 2 divided by x minus 2 and divided by y into x plus 2 whole square. So this x plus 2 whole square cancels, and basically we have 1x plus 2 left in the denominator, and then this y square cancels this y, so the answer we have left is 2y divided by x minus 2 x plus 2. So we can use the identity of a square minus b square over here. So it will be 2y divided by x square minus 2 square will be equal to 2y divided by x square minus 4 is equals to over dy by dx, and that is the correct answer as well, and that is what we have to show it's shown. Moving on to the second part. Given that k is equals to 5, find the angle between the tangents to the curve when x equals to 3. So k is equals to 5, x equals to 3, we can figure out the values of y. So values of y could be, we can substitute k is equals to 5 and x equals to 3. So if we do that here, y square will be equal to 3 minus 2 would be 1, and 3 plus 2 would be 5. So it will be y square equals to 1 over 5 into 3 minus 2 is 1, and 3 plus 2 is 5, so y square will be equal to 1 over 5 into 5. So y square will be equal to 1, and y will be equal to plus minus the root of 1, which is basically 1. So y will be equal to plus minus 1. So our set of coordinates will be 3, 1, and then 3 minus 1. Now we have to find the angle between the tangents to the curve when x equals to 3. So if we have a curve, let's say like this, and then we have two tangents across it, the angle between that will be tan theta would be m1 plus m2 divided by 1 plus m1 m2, sorry, m2 minus m1. So the derivative at y is 3, y is 1, and x equals to 3 would be 2y divided by x minus 4. So the m1, let's say, would be 2 into 1 divided by 3 square minus 4 is 5, so 1 over 5, and the m2 will be basically our uh, 2 into 1, 2 into minus 1, so minus 2 divided by, and this will be 2 over, this will be, sorry, 2 over 5, and this will be minus 2 divided by 5. Then we can use this formula, so it will be minus 2 over 5 to minus 2 over 5. It would be minus 4 over 5 divided by 1 plus 2 over 5 into minus 2 over 5, 2 into minus 2 over 25. It will be 1 minus 4 over 25. So if we rewrite this, it will be minus 0.8 divided by 1 minus 4 over 25, and that would be 21 divided by 25. If we divide 0.8 by that, the answer we will get is minus 20 by 21. So this will be our answer, but if we will have to take the mod, so it will be automatically positive. So our theta will be tan inverse 20 over 21 Right, and A would be 1 then, B would be 20, and C is 21. And that is the correct answer.
11. So the points A and B have these position vectors and show that the perpendicular distance from A to the line through OB. So if this is OB's line and this is A, let's say, from the origin, this is A. The perpendicular line between this part is called the distance between them. Okay, and we have to show that this is 1 over 3 root 65. So you have to show that the distance from here till here is that. So we can just let this point be x, and we know since they're perpendicular, so the direction of ax and the scalar product of that and the direction of scalar product of ob, sorry, the direction of ob will be equal to 0. So if we find the direction vector of ob, it is 4 2 4, and if we want to find ax, so ax would be equal to ox minus oa. Now ox lies on ob, so ox's vector equation is always supposed to be, since the vector equation of line ob will be equal to 0 0 0 since it starts from the origin, plus lambda into 4 2 4. So the coordinates of ox could be 4 lambda, 2 lambda, 4 lambda, and then we have ox minus oa, so it would be 4 lambda. So O is 2, 2 and minus 1. So 4 lambda minus 2, 2 minus 1. 4 lambda, 2 lambda and 4 lambda again. So the coordinates of the direction of AX would be equal to 4 lambda minus 2, 2 lambda minus 2 and 4 lambda minus 1, which is 4 lambda plus 1. So the scalar product of this and OB is 4 2 4 is equals to 0. So we'll multiply and get the square product. So 4 lambda minus 2 plus 2 lambda minus 2 plus 4 lambda plus 1 is equals to 0. So if we open the bracket, it will be 16 lambda minus 8 plus 4 lambda minus 4 plus 16 lambda plus 4 is equals to 0. So 16 lambda plus 4 lambda will be 20, and then 20 plus 16 will be 36. So 36 lambda minus 8 minus 4 will be minus 12, minus 12 plus 4 will be minus 8. 36 lambda will be equal to 8, lambda will be equal to 8 divided by 36, which will basically be 2 over 9. That would be our lambda. Now you can use this lambda to find the coordinates of ax. We have to basically find the distance of ax or the mod of ax. So absolute value of ax. So ax is basically 4 lambda minus 2, 4 lambda minus 2, 2 lambda minus 2 and 4 lambda plus 1. So if we write ax's value, so ax would be equal to 4 into 2 over 9 minus 2, which is basically minus 10 over 9, and then it would be 4 over 9 minus 2 as well, which would be minus 14 over 9, and then the third coordinate would be 4 lambda plus 1. So 4 into 2 over 9 plus 1 would be 17 over 9. Then we can calculate the absolute value by the square of this, then the square of this, then the square of 17 over 9. So if we do that, the answer would come out to be under root of 65 over 9, and it would basically mean under root of 65 divided by under root of 9, which would basically be 1 over 3 root of 65, and that is what we have to show in this part as well. That is the correct answer. number 11 is B part. The point C as position vector 3I plus Pj plus Q. So it is 3P, and it is given that OC is perpendicular to OB and angle OC is equal to angle COB. So we can use both of these values to calculate P and Q. So let's try. So OC is perpendicular to AB. What does this mean? The scalar product of OC and AB is equal to 0. And this is OA, this is OB, this is OC. So AB will be equal to OB minus OA, and it will be equal to 4 to 4 minus 2 to minus 1. So AB will be equal to 2 to 0, 4 plus 1 is 5. So the scalar product of 205 into OC, which is 3 PQ, will be equal to 0. So we can rewrite this as 2 into 3 plus P into 0 plus 5 into Q is equals to 0. So 5Q will be equal to minus 6 and Q will be equal to minus 6 over 5. So we have the value of Q now. And our first, we also use the first condition as well. Now the second condition is such that the angle AOC is equals to angle COB. So if we imagine this over here, angle OAC, so if this is the directions are like this, so we can use a dot scalar product formula. So the scalar product of OA and OC is equals to the magnitude of OA and magnitude of OC and into cos theta. So since same theta, so same cos theta as well. So we can make cos theta the subject. So cos theta will be equal to OA OC scalar product divided by OA and OC's magnitude. That is our first equation. Now for the second part, we have angle COB as well. So angle COB as well. So the same goes here. So OC's and OB's scalar product would be divided by OB's magnitude and OC's magnitude to calculate the answer of cos theta. All right, and then we can equate both cos thetas since they're the same. So OA and OC's scalar product divided by OA and OC's magnitude is equals to the square product of OC and OB and divided by magnitude of OB and OC. Magnitude of OB and OC are both same on both sides, so we can cancel them, right? And then one other thing we can do is we can now write their equations. So the scalar product of OA and OC will be 3PQ, and we'll multiply it by, or the scalar product would be by 2 to minus 1, 2 to minus 1. So it would be 6 plus 2P minus Q divided by the magnitude of OA, right? For this expression, the magnitude of OA would be under root of 2 square plus 2 square plus minus 1 whole square. So it would be under root of 9, which is basically 3. That is our first part. Then we have this part. So OC into OB. So 3PQ again multiplied by 4, and the vector of OB is 4 to 4. So 4 to 4. That would be 12 plus 2P plus 4Q divided by the magnitude of this. So magnitude of this would be 4 square plus 2 square plus 4 square would be equal to 16 plus 16 plus 4, which is the root of 36, which is basically 6. That will be divided by 6. So we can equate both of these now. So this will be equal to 12 plus 2P plus 4Q over 6. To remove the denominator of 6 from here, we can multiply this side by 6 as well, and we'll multiply the other side by 6 as well. And to cleanly do it now, we can cleanly write it as 3, and then this will be 2. So it will be 12 plus 4P minus Q, 4P minus 2Q will be equal to 12 plus 2P plus 4Q. This will be our main equation. Now we can, since we need to find the value of P, since we have already found Q, so we can make P the subject. So 4P, and then this 2P goes on to that side. So 2P will be equal to 4Q plus 2Q plus 12 of this, and this will be minus 12. So these two cancel. So 2P will be equal to 6Q and P will be equal to 3Q. The value of q we calculated earlier was what? Minus 6 over 5. So p will be equal to 3 into minus 6 over 5. So our p will be equal to minus 18 over 5, and our q already was minus 6 over 5. And that would be the correct answers.